Hello, this is Dr. Alberg, and I'd like to welcome you back to our course, Introduction to Reinforcement Learning Motion Control. The topic of our lecture is neural network controller deployment into the system hardware. What we're seeing here that Amazon, for example, they provide deploying capability and monitoring the policy. The policy is what we call the neural network controller. And what it says that after you train the reinforcement learning neural network controller, you can export the learned policy for evaluation and deployment. And you do it with what they call the SageMaker. And with the SageMaker, you can prepare, build, train, and deploy high quality machine learning. And Amazon SageMaker is available for free for 2 months if you want to try it out. Then MATLAB provides deployment of trained reinforcement learning policies. Again, policies is our new neural network controller. And once you train a reinforcement learning agent, you can generate code to deploy the optimal policy. And this can be done by CUDA or C or C++. Then IBM provides here a tutorial to create and deploy an application using what they call developer tools. And the developer tool, you can create an app using commands. You can build and run it, and then you can deploy it and view the system after you deploy it. Then Microsoft provides the deploying machine learning models to Azure. And the workflow for deploying the model, you register the model, prepare an entry script, prepare interface configuration, deploy the model locally to ensure everything working well. Then you choose some kind of a hardware to as a compute target, deploy it there and also to the cloud, and then test the resulting on a web service. And then Google shows us that you can build and deploy a custom object detection, for example, supervised learning, as we saw earlier, into their cell phone. And they're using their TensorFlow mathematics. And what it says over here, deploy the custom model to the Android app using some libraries. So what we see in general that once we develop the simulation by the system analyst, and then we embed that into the agent for the reinforcement learning training of our neural network controller, we do all of that on a PC. Once we're done with that, then we have just the neural network itself, where they get an input from sensors and they put an output to the actuator. Just that, it's a multiplication, matrix multiplication, nothing else. And then we can deploy that into the hardware or the motion controller. And over here we see, for example, Arduino. And that Arduino, that deployment will store that program inside the CPU, inside the processor. And then when we start it, there will be all these signals will come in over here. Digital signals from sensors and analog signals from analog. If you want like an exoskeleton, take it without any power, AC power. We can have an external battery connected over here. We have all kinds of functions that the hardware is providing us, and this is under the supervision of the computer, the electrical engineer that is providing it. The programming over here, once we download it, is the function of the computer scientist. Now, if we look at what Amazon is giving us, a tool to learn reinforcement learning. with a deep racer. Here's the deep racer. We saw it earlier. Here's the complete autonomous vehicle. Then we can deploy it. Over here is a USB terminal, and we can deploy it from our PC right into this CPU the same way as we saw before. And then when we're talking about Tesla, self-driving car, which drives over here, you see hands-free by itself, and it has vision in order to detect with supervised learning all these objects over here and identify them as cars or, for example, people that cross the street. This is also being deployed over here. It's a much more complex machine controller over here, but it's pretty much similar to what we saw before, with all the input from the sensors and all the outputs to the steering and the brakes. So with that, I'd like to thank you for listening, and I look forward to talk to you in our next lesson. Thank you.